We have this concept of defining a creature as a thing in memory and a wizard as a thing in memory, but they don't really do anything or have any behaviors or data. So let's go over here and look at this. Let's look at the creature first. So what might the creature have? Well, maybe the creature is going to have a level, and let's have it have a name. So we can say something like Toad of level 7, something like this. So there's actually several ways to add those features as data to this class. And the way that I'm going to show you will generate what are called instant attributes or instant variables. And these are only going to be tied specifically to a particular version, a particular created instance of the creature. So the data related to this creature will not at all be shared with this creature. There's a way to have sort of what you'd think of as static shared data. But we're going to use what's called a magic method. Now, to add methods, magic or otherwise, to classes, just like normal methods, you say def, but you have them indented into the class body. Now, I could have a method that's called runaway, like this, and then that would be a standard method there. But we're going to use what I said, a magic method. So magic methods start with double underscores, often called dunder. And you can see there are a lot of them. So here you can see length. If we had some kind of collection and we wanted to talk about how many items were in it, we could implement dunder len. And when somebody says len parenthesis our object, it would implicitly call this method. If we wanted to change how our creature appeared when you just said print creature with no special formatting, we could implement dunder stir, and then we would get some kind of special string representation. But the one we're looking for is dunder init. So here there's something a little bit unusual in this method. Notice when I hit enter there, PyCharm put this self, and this self has a color. If I had other variables in here, parameters, they wouldn't have this purple color. Remember, the class is the blueprint, and then there are the object instances, and each one of them has their own special copy of data, and that's what this self represents. This is the pointer to the one that is being used to call this method. So in this case, it's the pointer to the object that's actually being created in init. So we want to have a couple things. We want to have a name and a level. Remember, this is kind of like a Dungeon and Dragon type thing. So we have a name and a level that you have to pass in. These are not optional parameters on the initializer for creature, as you'll see in just a minute. And then the way we define instance variables is we use this self parameter, and we just say something like self.name equals name and self.level equals level. Now, these don't have to match. Let's just change this to like the level to make it really obvious that there's no real name relationship between them. But self dot, this is actually the creation, the definition of name attribute or field in the creature class. It's highly discouraged to do this outside of the init method. Now, while we're at it, let me show you a cool PyCharm trick. So if I had another thing here, like let's say experience or whatever, notice that it's not assigned to any member variable or used in any way. So I can come over here and in PyCharm, I can hit enter and said, add this field to the class. And bam, it'll go here and automatically do what you just saw me do. So we're not actually going to have this experience, but you can use PyCharm to kind of automate this. It's very nice. Now, it turns out that the wizard is going to be very similar. So let me copy this over here, and I'll just change this from the level to level, like so. So now we should be able to create our wizard and create our creature, and they should have data associated with them. Then next, we're going to give it behaviors, like maybe it has an attack method here, and it can attack an other creature or just a creature. And down here, we'll put something that has to do with attacking the creature. So I told you that these are required. If I try to run this app again, it's going to crash. And it crashes right here and says, whoa, 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 whoa. We are missing two required positional arguments, name and the level. I can do things like give a default value. Like, so I could say by default, the level is 10. Unless they specify it, then it'll be something else. So then you'll see only one required parameter is missing, because if you don't specify the level, hey, it's 10. It's all good. That doesn't actually make a lot of sense in our particular game here. So I'll take that back away. All right, so let's go figure out what's wrong and fix this. So I can just click right here and navigate right to where the error was. And you see PyCharm has this kind of lit up in color here saying, not such a good idea. All right, so what do we have here? We have the name. Remember, let's see, we had a toad, and the level of a toad was quite low. We had a tiger, and the level of a tiger was moderately high. I think we had a bat, and the level of the bat was not particularly high. It was 3. We had a dragon, And the level of the dragon was pretty high. And we had the evil wizard. So now our list of creatures will actually contain particular copies of the creature object, 5 of them. And each one of them will have a separate name and a separate level tied together. One thing that's a little bit off here is using this creature class for a wizard when we also have a wizard class. So let's leave it like this for a minute and we'll get back to it. So now here we have the same problem. We have exactly the same requirements to create this. So let's say this is Gandalf and his level is 75. Okay, let's run this and see if we can get down past line 27. Looks great. Let's actually run it in the debugger and we'll have a look at these in memory. So here we are at a breakpoint. We've got our local variables and we have a hero, and you can see we can open this up. We have this hero has a level 75 and his name is Gandalf. We actually have a list of creatures, and you see there's various creature objects. These are manifestations or things created from the blueprint of creature. They're at different memory addresses. Everything in Python points to somewhere in memory. And so the elements of this list all point to different places, and the debugger happens to show you that if you really care about it. We can open this up and see there's our bat, there's our tiger, there's our toad, and so on. So we spoke a little bit about magic methods, and you can see that this is not the most amazing experience for looking at what is in this list of creatures. And that's not the only place it showed up. If I were to come in here and just say print the creatures, and I run this, you can see basically we have the same output here. There's some kind of actor.creature at these various addresses. And we can use the magic methods to change how this works. So in my creature, I could come down here and I could say define dunder repr for representation. And then I could just say return some kind of string. So let's say creature of the name of level something there. We'll do a little format like so. And so we can say self when you refer to the variables of the particular instance of the type of class. Like so the particular creature here, I'd say self.name and self.level. Of course, maybe format instead of forma. We'll have a little better chance there. So we're going to return a string that can be used in various places. So now if I run this, you can see we have a creature toad of level 1, maybe like so or something. Creature toad of level 1, creature tiger of level 12, and so on. So we're only getting started with our classes and modeling the actors in our game, but you can see we're already off to a good start. We have a list of creature objects that have their particular data associated with them, and we have our hero, which is a wizard named Gandalf of level 75.